Hi, welcome back. In this video we're going to look at the slope-intercept form of a linear equation. Here it is. So the slope-intercept form is y equals mx plus b. M, the coefficient of the x, is the slope, as we saw in the last video. It tells us whether the line is increasing or decreasing, tells us how the y-coordinates of points on the line change with respect to x, changes in x. We also get some additional information. If we let x equal 0 and then solve for y, we will get the y-intercept. Well, if we set x equal to 0, this term goes away and we're left with y equals b. So the point 0, comma b is the y-intercept of the line. So this form is very useful, and it's typically the form that we like to have lines in because it tells us this information just so readily. So we get the slope, coefficient of the x, and we get the y-intercept. Okay. And why it's called slope-intercept form. All right, let's go ahead and try this for a linear equation. So here's one in standard form. It's 12x minus 4y equals negative 9, and then we want to put that in this form. Y is by itself on one side, and then everything else is on the other, written out as mx plus b. So what we need to do is we need to solve this equation for y. So we've got the negative 4y here. That term we're going to leave on the left-hand side and move the 12 over. So we've got negative 4y equals negative 12x minus 9. All right, and now to get y by itself, we need to divide both sides by negative 4. So I'll divide by negative 4, divide by negative 4, and divide by negative 4. When we do that, we want to divide every term on both sides by negative 4. All right, so we get y over here. Negative 12 divided by negative 4 is positive 3, so 3x. And we have negative 9 divided by negative 4 would be plus 9 fourths. All right, so y equals mx plus b. And now we can read off the information. So the slope, the m, is 3. And if we wanted the y-intercept, we could also say that. It's going to be 0, comma 9 fourths. So y-intercept. Okay, so that tells us all about this line. 12x minus 4y equals negative 9. All right, pretty handy, no? All right, let's look at another example. Here's another example, another line in standard form. We want to express this in slope-intercept form, and then we'll use it to graph. So I'd like you to pause the video right now, take this linear equation, and do exactly what we did here. Find the slope and the y-intercept, and do that by putting it in slope-intercept form. Okay, how'd you do? Let's take a look. So we've got negative 2y. We want that by itself. So negative 2y, we'll subtract the 6x. So we have negative 6x plus 4. Then we need to divide by negative 2. We get y equals 3x minus 2. All right, so the slope is 3, and the y-intercept is 0, negative 2. All right, now we can take this information and use it to graph the line without plugging in x values, finding y values, and getting a set of points. We can just use the intercept for the first point and then use the slope to find other points. Here's how we do that. So let's start with the y-intercept, 0, negative 2. Start at 0, down negative 2. So there's the first point. Now the slope, remember, characterizes the rise of the function over the run. 3 can be thought of as 3 over 1. So there's a change of 3 units, the positive direction in y, for every 1 unit change in x. So if we move over 1 from this point 0, 2, we're going to go up 3 units. So we go over 1 and up 1, 2, 3. So that's 1 over and 3 up. If we want another point, we can just go over 1 more and up 3. 1, 2, 3. All right, and that gives us our line. So line that up and sketch our line. All right. So given a point and the slope, you can always plot additional points or that are on the line. If the slope is negative, you would either take your x value and go that many units in x and then down in y, or you could go in the negative direction and then go up. As we could here, if we started up here, or let's say right here, at our y-intercept, we could go back 1 unit, negative x, and that would require us to then go down 3 units in y. It would be like taking negative 3 over negative 1 for the slope. We can see that here. If we go negative 1 in x, and we go down 1, 2, 3, we get, so it's negative 1 and negative 3. Okay. From here, we're going to, or in the next video, we're going to look at being given the slope and a point and seeing if we can recover the equation of the line, which we can, and we'll need a formula for that. So stay tuned.